All right, so our nice opener here for the course guide is actually pretty similar to the geopack drainage course guide. We transferred over quite a bit that still applied, basically explaining the capabilities of the system, what designers can expect to use, what's available for modeling. I think you've all had a chance to read through this, but we can definitely make some updates if needed. And another note for today, anywhere that I've got red text is kind of a trigger for me to bring up to the group possible discussion pieces. So in this particular case, as we've started explaining, can do runoff computations, inlet design, and now we're getting into ditches. I think it's more than just trapezoidal ditches that will eventually be able to be designed and analyzed. But the potential topic of discussion here is we haven't produced any output that would be a standard format from a ditch calculation. So keep that in mind. I don't know if we need to resolve this currently at this moment, but later on this afternoon, once we get to the drainage documentation chapter, if you think it's worthwhile to include ditches, we can do that. But generally, this course guide is just introductory. It's more of the standard entry-level topics, and we do plan on putting together advanced topics, of which I think ditch design could be one. Okay. So the goals of this entire document, that's probably worthwhile to just repeat here. So after successful completion, and this includes our time today, we're going to learn where to find additional resources, all of the background information from the resources, the workflow, the file types used, how to create a drainage file, navigating through the software, the delivered features and components. So that's going to be the various inlets and pipes and manholes, etc. We're going to lay out a network and edit it. I'm going to create custom drainage features, and if you haven't been tuned in to date, this is alluding to our J-bottoms and other non-standard or non-P-bottom structures that are not part of the delivered workspace. We're going to create some drainage areas, set up the computations, be it the design priorities and constraints. We'll review the computations, create a drainage structures plan sheet along the FDM 916 criteria, and we'll get into drainage documentation. This expectations is mainly setting up that we're not covering every piece of information and theory and how-tos that are part of the standard Bentley product. Some of it we have to cover kind of by necessity, but a lot of this information is really well covered in the Bentley documentation, so we're pointing folks to, if there's questions, that's where to find them. There's a little bit of a document style preface. So we have quite a few references to file paths, and we're bolding where there's an instruction to select or click. So from a formatting perspective, we'll probably have to make some updates to make sure we're consistent there. All right, so into some of the background of how Open Roads drainage operates. Basically, all of the design information for a model is contained within a single DGN. So that's our microstation design file. So be it plans information, inverts, 3D locations, all of the database, pay items, etc., for a single project or a single network are going to be contained only in that DGN. But how that file is informed and the basis of it is the DGN library. So that has all of the standard basic setup and the templates that are there that get imprinted on a drainage design file once it's created. And also there are cells. So the typical cell library includes the 3D cells for all the drainage structures, all the tops, all of the bottoms are there. And it's just, when we'll get to this later again, once we'll come back to the J bottoms, the DGN lib does not create every iteration of the top and bottom cell combination. So that's where it becomes somewhat important for users to understand the background of how things are connected so that when it comes time to create something they need to use, it's a little more clear. All right, so this page has a variety of links out to the Bentley training. They've got some communities where there's FAQs and just users that have specific questions that get answered. In fact, I'll go ahead and just click on one of these so you can see what it looks like. It's got a pretty user-friendly layout. It has the same ribbon topics that are, once you open Roads and you're in the drainage and utilities workflow, all of the tabs that are at the top, the home, layout, analysis, etc., are all there. So if you want to click on anything, it kind of goes down a path. It's all there. It's a pretty useful help menu. There's not too many gaps in information from what I've seen so far. And once we post this training to the CAD website, we'll have the course files. So that includes kind of the zip folder that you received today, but probably in a more FDOT folder setup. So more introduction to the new workspace. The function keys are quick toggles on and off for things. I found F11 becomes quite useful in this course guide to pop open the Project Explorer. And actually, probably some of those function keys that I have is do a different way of getting to different views we could look at updating as well. But basically makes it easier to quickly navigate the interface there. So here we're talking about just the general design of drainage in open roads. It hasn't changed from the general process that FDOT has always used, but it's just looks a little different. So this is kind of describing the process, creating a new file, create inlets, areas to inlets, link them with pipes, run the calculations, do iterations as needed to meet criteria, and then create your deliverables. So additionally, there's some more setup. This is consistent with the kind of the roadway course guide as well, as far as how to set up the workspace so that buttons are in the same place as they are in the examples. So I guess we could start here. Yeah, why not? Let's do it. So if everyone wants to open up their FDOTConnect, you can do it from the Start menu. Then we're going to find the FDOT workspace. and we're going to create a new template. All right, so FDOT Workspace, I'm going to create a new workset. And in this case, I'm going to copy paste the name of the workset to our chat. And it's also shown on my screen. This is the FPID project that the roadway course guide is using, so it's consistent with theirs, and it'll be consistent with the screenshots that are in the course guide. So under templates, going to select 0 workset template. So what that's going to do is just copy what the installation had as far as the standard folder structure. And then we're going to click OK. I'm going to move this up here. There we go. All right, so once you've created it, it's populated in this pull-down list. So you'll go ahead and select that folder, and we're going to browse to that folder. And we're going to open up the blank file that's in it. So just to recap, creating a new workset. So once you've got Open Roads open, clicking on the new workspace, selecting FDOT, and then clicking over to the workset. So FDOT is on the left, the pull down with the workset template is on the right. And at the bottom of that pull down menu, you have an option to create a workset. So then you'll click OK with that, and then the new menu will pull up. Where we're a little bit different in today's exercises versus the guide here is that instead of new test workset, we're going to rename it to what I put into the chat. It's a 22049555201_CE. And then you can make one more selection to use the 0 workset template as the template, the third line from the top, and then click OK. All right, so is everybody up to speed there? We've created the workset.
Question for the description, what would you like us to put? Same thing?
It doesn't matter. If you want to just some notes, you can kind of follow through where that is going to show up in the various properties. And then once you've created
my system crashed, so I have to.
Oh no.
Sorry.
No, it's okay. Today there's
the system crashed, so I have to start again.
No worries. Yeah, there's a few crashes probably bound for all of us today, unfortunately. But
another thing, I have that workset already. I think it's from the previous meeting that we got.
okay.
I have it already, yeah, in my system for some reason.
All right. If that's the case, you're probably okay, except I would probably delete anything in the drainage folder.
Okay.
We want to just start from scratch. So basically what we're doing with this workset is creating a blank set of folders, and we're going to copy in just a few select files for attachments. So yeah, I would just delete stuff so that it's not going to get in your way.
Yeah, it's drainage, right?
Yeah, just drainage. The roadway files are probably fine to stay where they're at. The surveys should be fine too. And then the last step is to open the blank file. from the new folder. So that's where my screen is at now, is showing the blank file. So I guess we've had a few crashes, but does most everybody have the blank file open?
Yes.
Okay, great.
Yeah, again, just raise your hand if you don't, and then we'll know to be slow up a little bit.
Hi, Angela. I've got a question real quick. What did you name this work set?
It's in the chat, and it's this, I guess you can't see my screen as I'm copying the chat. Let me go back to our,
It's up at the top of your screen there. Yeah.
Oh, I see.
Your MicroStation screen is right there.
Okay, thank you.
yep. All right, so first part of the workspace is knowing what the workflow you're in, and that's at the top left, and there's a pull-down menu. For me, it came up as drainage and utilities. It may have come up as something else for you, which is okay. But if you go to Open Roads Modeling, the top one, that refreshes the tabs in the ribbon, and there's an FDOT tab. So from there, I'd like everyone to go to the left. So, and we'll just go ahead and start getting some of our semantics consistent. So we've got ribbon tabs, and then within a specific ribbon, there are groups of tools. So the groups here are selection, action, cell applications, roadway, etc. So in the actions group, there's the create file tool. And if you bring it up, we've got a window with a few pull downs and more options. So just for completeness sake, you can see there's all the various disciplines. Today we're going to be just in drainage. And then once you select the discipline, then you'll have some options for what group of files. So we've got design files, which are going to be our flood data, optional materials, drainage structures, ponds, text, and then the sheet files, there we go, that updates to the more sheets that go into a plan set. So we're going to go to design, and DRPRRD for drainage structures proposed is going to be our new file. So the file sequence, if your folders are blank, should populate at 01. And if you happen to have something else, it's pretty good about bumping it up to the next available number. The output folder by default is going to be drainage, and it's going to use our default seed file for 2D DGN, which is fine. For this project, our county is Wakulla, and the coordinate system may automatically populate, but it's the North Florida. So once everybody's ready, go ahead and create and open. So it's going to take a little bit of time to do its thing. Hopefully, no crashes. All right, so on my screen here, the create file tool is still open, but we can go ahead and close, and then you'll see at the top of the screen, I'm now in a file that's named DRPRRDO1. So does everybody raise your hand, I guess, if you're not able to have your DRPR file open? All right, I'm going to flip back to our course guide here to take us to the next steps. The ribbon I kind of described and the different groups of where things are at, but let's go just browse the drainage and utilities ribbon first. So you'll see the top tabs range from home all the way to view, and I'm just going to kind of quickly go through these. We're going to get to these as we get into the examples, but just so you can see where there's familiar tools for MicroStation just kind of tucked into a different spot. So home on most of the workflows has your typical attachment, reference, information, levels, that sort of thing in the primary group. Your select tools are there, and then you get into more, for drainage, some of the terrain tools. Layout is where you'll go to place any drainage elements from structures to pipes and profiles. Analysis is where we're going to set up all the calculations, where we'll run them, and the analysis views and flex tables shows up in a few spots, but that's one place to see some of the results. Components is where the DGN library kind of basic setup of the hydraulic properties of the structures and pipes and rainfall have been saved. I think one of our exercises, we're going to get into these here shortly. Utilities views. It's another useful type of tools to do queries, make selections, look at things in a certain way. Actual tools is you've got options to do some updated user data extensions that we have a few for FDOT that help add fields to the database properties of the drainage elements. It's where we may have to activate a license if you haven't done so yet. It'll be the StormCAD. Report is a variety of out-of-the-box reports that Bentley has created. Some of them will possibly be useful for our drainage documentation for FDOT. Others, we've refined to create our own custom tables and reports. Drawing in production, that's just placing labels, placing text, model annotation, and also getting us started into cutting sheets. Drawing just has your same old drawing tools, measure tools, and view has a little more options. A lot of these buttons are already in your view window. Okay, so now that we've explored all of that, let's go back to our course guide here. So we're going to create a new utility model. So right now our DGN file is just a DGN file, nothing more. So to create or to place drainage structures, it's got to go through this process of imprinting all of the templates and background from our DGN lib into this specific DGN. And to do that, you can go to any of the layout tools, and it won't let you lay anything out until there's a drainage model. So you can click Place Node or anything else, and you'll come up with this, you cannot undo this action prompt. It'll create a utility model in the design file. Proceed, and we're going to say yes. So it takes a little bit. It's got a lot of information to populate in the background. Anybody having trouble getting to this point? All right, so another way to confirm our drainage model has been created is to look in our Project Explorer, and I think that's the F11
Mic on.
toggle.
Mic off.
We'll toggle it on and off, and there's more tabs. In the Explorer tab, click on the Drainage and Utilities model, and then you can expand and see any models that are within this file or attached to the file. So we've got a single model under our DGN, and right now we have no nodes, conduits, drainage areas, or profiles. But once we start populating, this will be a place where you can manage them. You can select them, and then from there, perform a number of actions. All right, so that was the end of the introduction. Everybody ready to go to the drainage library? Okay. So this gets into probably more than you ever really wanted to know about what's in the drainage resources, but I promise it does become important later on. So looking into what's part of the DGN lab, there's top level, the umbrella that holds all the information, both hydraulic data and the symbology, how the lines are drawn in 2D and 3D, are under feature definitions. So part of that, the symbology, there's a few pieces and parts that go in to define that. And then our hydraulic seed data, there's buckets that hold that information as well. You've got the catalog, prototypes, and storm data. And just another example of how we're describing paths. So we've talked about the ribbon a little bit in the drainage and utilities workflow, in the components tab, catalog group, then the catalog tool. So I'm just going to pop over there real quick and kind of explain what that piece of text is meant to look like. So drainage and utilities workflow, components tab, catalog group, and then catalog. And then from there, you've got a range of catalogs to open. So I kind of described what feature definitions are and what they're used for. Anything in italics in this course guide is a snippet from Bentley on how they describe things. And in this case, I think it's pretty useful. So there's feature definitions in the drainage world for nodes, conduits, and polygons, which are used for our drainage areas. The symbology has a few levels of information that all kind of link together. I think the easiest way to describe it is with this graphic here. We've got, at our base level, we've created cells. We've got 2D cells and 3D cells with lines and symbology that are levels that they're all on. So our cell library is referenced by an element template, which we've created for every single type of drainage structure, top and bottom. And there's separate ones for tops and bottoms. Then a feature symbology references that element template, which is then referenced by the feature definitions. So the feature definition houses both symbology and hydraulic data, but this is the path for how things get drawn. Then the other side is the hydraulics. Our catalogs and the prototypes define the hydraulic properties of structures and pipes and drainage areas. And the dash here is meant to kind of explain that catalogs aren't necessary for a prototype to exist, but prototypes can reference catalogs. So for the FDOT resources, we have catalogs for inlets and gutters and conduits, and then our prototypes reference those, which are then referenced by the feature definitions. So this is just a snapshot, but I'm going to have us go into our components and into the catalog group and open up the catalog for inlet catalog. So we've got a list on the left of every type of FDOT inlet, and as you scroll down the list, different properties are going to populate on the right. So just for discussion purposes, I'm going to go to type 1 curb inlet. So the properties we get to choose from, and this is all kind of HEC 22 type assignments is how the software is built off of. So this is a true curb inlet. We give it a width and a length, the curb opening, width and length, and slope and depression, throat angle, all of that. So that's part of the hydraulic properties that go into it, but not everything. But then there's also 4 tabs at the top, just to note. So design is empty for all of our structures. The only reason to use this is if you wanted a variable opening. So if our curb inlets could open from 10 feet to 10 and a half, 11, 12, which they can't, but if we wanted them to, this is how we would do it. And then library notes. We've populated some of the assumptions and background information that goes into the properties that have been entered. So if designers have a need to do something differently, they'll at least know what the starting points were. Okay. All right, I guess while we're here, we can also just quickly pop into the Conduit Catalog. So same place, down the list. So early on, we were trying to decide, how much of the properties do we want to populate. The original goal was just to mimic the function that GeoPack Drainage did. So there's a few extra templates in here, which may or may not be useful for most projects, but typically circular concrete are what folks are going to design to. So the way the software works and why we're doing a catalog for Conduit, and unlike the structures where we have a feature definition for every different one, every different version, pipes are all under one. And so this allows the software to design. It'll, after it performs the hydraulic calculations, if it sees it's under capacity, it'll go to the next size down the list, and so on. And so we can see all the hydraulic properties are in the table to the right, including our standard wall thicknesses. And again, we have notes kind of describing what's here. So if a project needs to change it for whatever reason, we'll understand the basis of what's there. So we've got, and if there's a reason for folks to, say, model gutter drains that are not going to have a 0.012 Mannings, then we have options for that as well. Going to wait to talk about ditches and the differences between conduits and gutters when we get back to the course guide, but there is a good distinction worth noting there. Here we are. All right, so...
I'm sorry, I had a question.
Yeah, absolutely.
What about French drains? Because I see everything here, but I don't see anything that says French drains.
I think we had a feature definition so that you could place a French drain, but I don't, there's no modeling. The catalogs and the prototypes are just for the hydraulic properties, so there were no modeling aspects of French drain that have been incorporated to date.
Okay.
But Giancarlo,
Yes, sir.
we've also created roadway templates in the FDOT template library, roadway template library, where you can model French drains. But since there's no hydraulic calculation, you can model them with your roadway template tool and just create an alignment with a profile and then run a French drain profile. I think there's 4 different types of those drains in there. I can't remember exactly. Actually, Angela, if you want to bring up, I'll show you where those are at. If you can show us your FDOT. Then you go to the open roads modeling, go to corridor, and then the one right under says template. Move over one, right there, just go to create template. And then you want to go to File, Open, and navigate to the FDOTConnect workspace. Org Civil, and then there's a template library down in that folder. FDOT templates or template library, open. And then the Civil FDOT one. You open that up.
I mean, Workset. No.
There they are right there.
Okay. You went way too fast right now. Can you just, in the Workset?
You just hover over the top folder.
Oh, okay.
Hover over the top folder there. It's Org Civil, and then there's a FDOT folder, and then it's in the template library folder. There's a Civil FDOT. That's our default delivered template library.
I'm just going to take a quick picture. Can you cover again, please? Okay. Perfect. Got it. Thank you.
It keeps going away.
So you can see there we've created what, 4 or 5 of them, I guess. So there's a trench drain, under drain. They're all a little different. These are based off of what was in the standards.
Okay.
So you can model them that way.
Okay. Sounds good. Thank you very much.
Yep.
All right.
Angela, I also have a question because when we use circular structures, they still show us a square when they are drawn.
Sorry, something about circular structures?
Yes, when we need to use a bottom circular, how do we change that? Because I changed it in the properties, but in the model, it still shows like a square.
Are you talking about drainage structure bottoms or
You're talking
drainage pipe?
Yes, drainage structure bottoms, I'm sorry.
Oh, okay.
I think we have an exercise to cover that, right?
Yeah, we'll get there. And I think we will cover the exercise about creating a J bottom. But basically, all of the feature definitions just have one version of a inlet top and a P bottom. And yeah, you're right. In some cases it's circular. In some cases it's square. But we'll be probably wanting to create a new feature definition for that case if you want to change from a circular to a different bottom. But yes, good question. All right, so just a quick note about how the hydraulics are run. Pipes and conduits, or pipes are considered conduits. So it's having flow from one structure to the next. And bypass is where gutter calculations are calculated. So anything, so our inlets that are not 100% effective, a gutter is required for bypass calculations to work. So previously in GPEC drainage, you would just say, if it bypasses, have it go to the structure. It's a little bit more involved with open roads. That's all. So that being the case, our catalogs for gutter and conduit have both, particularly ditches and gutter. Actually, just ditches show up in both. So if we go to the Conduit Catalog first, you'll see we have ditches. So the context in which a ditch would be a conduit is if you've got a series of side drains that you're modeling where all of the flow goes out of a pipe, out of an outfall of a structure into a ditch and into the next structure. The case where we go back to our inlet, our catalog for gutters, it has our, pavement surface, the typical gutter application, but it also has some ditches in case somebody wanted to model bypass from one ditch inlet to the next. All right, any questions on that? Okay. So moving on to prototypes, catalogs had some high-level information as far as the hydraulic properties go, but prototypes, refer to that and add to it more in like a setting, kind of giving some default heights or widths or placement ideas. So let's go to prototypes. Here we go. And I'm just going to minimize everything so you can see the whole list of the realm of prototypes that are covered in drainage and utilities. And if it has a plus sign, that means it's present in this model as far as the definition goes. So for our pipe conduit prototype, we're giving it some additional settings that are going to be used in the calculations. Is it up for, can you design it? Is it a conduit or is it not? Is it a culvert, which they model culverts differently than conduits. So that would be your side drain application where it's just a standalone network. Manning's in, number of barrels. So a lot of this is where the properties refer back to catalog. So all of this is automatically populated for the most part. Generally, I don't think users or designers are going to have to modify this unless they want something that is non-standard. Most of these are based off of the FDOT standards. There are some ditch templates. So in the catalog, we gave it some geometry, but this is, again, telling the software how to use it in a calculation. All right, gutter. We've got various roadway or shoulder slopes that are defined. Catch basins, these are all of the inlets. So let's open up that type 1 comparison. So before it gave us just properties of what's the opening width, depression, dimensions, that sort of thing. But this gives us more design attributes. When we place it, do we want the pipes to match? That sort of thing. And you'll see in here we also have some FDOT additions to help populate the database. So all the prototype hydraulic properties feed into the model and its database so that we can do reporting in our documentation can reflect different things. So in this case, we want our plans to tell us what the type is as FDOT's named it, since this is where that shows up. Okay. All right, so there is an important reminder here of whether things are retroactive or not. So let's say somebody needed to change something about a prototype. Let's say they wanted to make a modified type 1 curb inlet and change something about it, and they used the prototypes to do that. If a structure was already placed in the file, it would not be retroactively updated. So when we do place a node, it imprints a one-time transaction of information from the prototypes to the actual structure. So a change in the catalog or properties does not get reflected. All right, storm data. We actually have an exercise that we're going to set our file storm data information, but all the IDF curves for the various zones are here. And additionally, we've added a storm for the spread calculations that's just a constant for each per hour. All right, so let's go to exercise 1.1. We're going to go back into open roads. We're already in our file. And we're going to test out that function key F11 to open up Project Explorer. And we're just going to open up a set of properties to kind of reinforce, what does the feature definition look like? So if you don't have Project Explorer up yet, I'm just going to hit F11 that shows it toggling on and off. And in the Open Roads Standards tab, you can expand that down. You'll see libraries, which you probably don't want to expand. It'll take a little time. That's going to reference our overall DGN lib, and feature definitions, which actually these are not going to be populated just yet because we haven't placed anything. So let's take a step back. Let's go into the libraries and give it just a moment to process there. All right, so once it expands, we're going to keep going into feature definitions. It's going to be the middle one, Sioux drainage. And I'm just going to go into the node tree down to stormwater node, drainage structures, and curb. And going to right-click to open up the properties, just of a random curb inlet. For the ones that are directional, there's not an easy way to rotate, so there are left and right variations. So the elements of the feature definition in this setting are not editable, so everything is grayed out. We've got the name, description, the name seed is what's going to come up as default when you place it. It's going to have that S- prefix, what type of structure it is, its default height, which we're making some updates to those. I know we've had some issues with structures being too deep, and part of it's based off of this default height value. So what we'll be updating the resources for is to have a structure be as shallow as would be per standards. So the smallest, shallowest pipe size, what the bottom is going to be for that. Whether or not the inlet matches the slope of the surface, let's say we got a 0.3% grade on the curb and we want our curb inlet to match, that's the true value there. Yeah, just some more information. So here's where it's pointing to which prototype is going to populate the hydraulic properties, and then the symbology down below is pointing to the various point, connection region, and solid feature symbologies. So it shows up in a few places. You've got the 2D view, plan view, which is the point, and then the solid would be your 3D views. So just a little bit of a primer before we go creating feature definitions. All right, and if you want more detail, I kind of went over those pretty briefly, but we've got those described in the course guide. So let's go create a new catchment prototype. That's another probably good point of discussion here is what's available, what are the capabilities of this software versus maybe what we're used to using and seeing. So if everybody could go to the Components tab, Catalog group, and open up Prototypes, and you're going to scroll down to Catchment and see the list that's there. So a little bit of background of how Open Roads places drainage areas, or what we're used to seeing rather. In geopec drainage, it would automatically recognize the land use and calculate a weighted C value, and that is no longer the case in the current edition that Bentley's put out for Open Roads. So that being the case, we have a few prototypes for drainage areas so that it automatically populates a C value that's associated with grass, multifamily residential, buildings, pavement, etc. So from a useful functional standpoint, either designers can place multiple drainage areas that drain to a single inlet and split it up by, this is my grass area going to the structure and this is the pavement area going to that same structure. Or the process we're going to do now would be part of the tools into helping them create. Say, I feel like I could just automatically calculate, or if I have a typical cross-section that has 80% pavement and 20% grass, and I know what my weighted value is going to be, that might be a time where if I'm going to use it repetitively, I may want to create a prototype so that I don't have to edit drainage areas after the fact. That's not to say that, let's say I place a grass drainage area and I decide, oops, it has a little bit of pavement. You can modify the C value after the fact once it's placed, but that's on an individual basin by basin basis. Okay, so let's go to the upper left where it says new, and that has now automatically populated this catchment prototype -1. You can rename it if you want. I'm just going to leave it as is and double click to open up its properties. So the goal of the one that we're going to create here is that scenario where we have a typical distribution of pavement and grass, and it's going to be kind of a mixed use. So we're going to fill in, we do want it to use the scaled area. So another just note about Open Roads, if you're asking, well, what does that mean? It has usually a good description at the bottom of what that field is for. So in this case, when we draw an area, do we want it to use the calculated area, or do we want to have to hard code in something? I'm not a fan of hard coding, so we're just going to say true for this. And from a inflow wet, that would be if you wanted to, here we go, set up a list of inflows directly injected to the system at the node. So let's say you've got base flow going on. And in this case, that's not going to be what we're going to use, so we're just going to leave that blank. Use local rainfall. This is, we've got global rainfall definitions, or you can say, no, if just for this specific area, I want to use something that's defined locally. So that's going to be false for this. The runoff method, we're going to use, let's do the pull down menu. You've got unit hydrograph, modified rational, or rational. So we're going to go rational method.
Quick question.
Sure.
What's the difference between the local and the global?
Local and global, we'll get to that in a minute. Once we get done with this prototype, we'll go visit the rainfall and see how the global definition of rainfall is applied, and then how we would go to it and change it locally.
Okay, thank you.
Okay, so rational method changes the other definitions. Is it defined by a single area or multiple sub-areas is one, which I'm going to say multiple. Then that opens up this new menu item here for sub-areas. And if you click the ellipse, it's now asking for me to define what those sub-area properties are. Not the actual acreages, but what are the C-value values. So I'm just going to say it's 50% and it's a free-form text. So I'm going to type in pavement and give it a 0.95 runoff coefficient. And then the other 50% is going to be grass with 0.2. So then we don't see it here. It doesn't give us a weighted C value, but once the calculations are run, we'll be able to verify the flows are based off of that weighted C value. All right, so TC input type, you can do a user-defined or a composite TC. I think that if you did composite would probably give you a mechanism to go through some more defined TCs, but I'm going to back out of that. And we're just going to say it's going to be user-defined. So, and our minimum is going to be 10 minutes. So there's no save. It's once we close this property box, it's done being edited. Let's say for notes, I'll go ahead and just put this as a project-specific mix. So if it comes up in any of our flex tables where there's notes, we'll be able to see that. All right, get us caught up on the course guide here. So what we haven't done in this particular step is take it to that one last final version for it to be really useful for me to place a drainage area with those properties. I'd need to create a feature definition. We're not going to do this here, but I probably will add that step just in case folks will find that useful. All right, so now we're going to get into the rainfall. And first we're going to set the global storm event. So back into Open Roads under the Components tab in the Common group under Storm Data, we're going to select Global Storm Events. Actually, strike that. We're going to select the other one first under the Storm Data, and you'll get to see the full swath of available information. And then we're going to go set our storm. So just in case you're curious, all of this was transferred over from Geopack Drainage, the IDX curves for the various storms. The storms go up to 50 years. And then I don't think we have any notes on that. And then the 4-inch storm is just carrying it for 2 hours as needed, but really it's just going to see 4 inches per hour for those spread calculations. All right, so now we're going to go back to global storm events, and what this is going to do is give us an option to pick from that list of curves, IDF curves that we found. So for this one, this example, we're going to pick zone 2, 3 year. And anything in yellow is just predefined. You don't have to worry about changing anything. And the general table here is set up for a variety of different types of hydrologic calculations. So not all of it's applicable for a rational storm. So all we have to do here is select zone 2-year, 3-year, and click close. And it's kind of skipping ahead, but I'm just going to quickly touch base on where the local rainfall would be. If you tab over to analysis and open the alternatives, and there's a whole variety that we're going to explain in further detail. I'm going to click on this rainfall runoff alternative, and there's kind of basic default definitions for all of these. And if you wanted to create different scenarios, you'd create new alternatives. So it is recognizing our global rainfall we just set as a zone 2, 3-year. However, we haven't placed any structures yet, but once we do, they'll be populated in these tabs that represent the actual elements in our model. And there's the column here for use local rainfall. So that would be telling the system, no, I want to ignore this zone 2, 3-year just for this structure. And my new definition for rainfall for this structure is here. So did that answer the question?
Yes, thank you.
Yep, cool. All right, so that was the end of chapter 1.